Why now? What is the reason? There are so many things in AI which are going on. Why didn't this work 2 years back? Claude over GPT-5, Gemini, they can do multi-step planning. That was not true in 2023. Let's pin down the three things people constantly confuse about. A chatbot, a RAG system, an agent sits a level above both of them. It plans, executes, and reasons about intermediate results. 40% of enterprise applications will have task-specific AI agents by the end of 2026. Very good afternoon to everyone. It's going to be a pretty interesting session today. Before I initiate the webinar, I would love for you guys to basically give an idea what you're looking from this. There are a lot of things which are happening in the AI world across the globe. I was in Singapore, just came back from Singapore and seen a lot of activities, and we were exhibiting there. We got finalists in the Supernova competition. In March, we were in Cairo and won that competition. It's a GTEx event. So there are interesting things going on in the AI world. If you guys want to know like what we are doing, we're involved into Krigat, which is a computer vision product in UK, and then we have Yugyog.ai. So there are a lot of things happening even at mine. But to start with, I would like to keep the floor open and start interacting before we jump towards like I'll explain the agentic system, agentic framework, a little bit of theory. Then we'll jump towards a practical implementation guide too, which I'll just share my screen, show the code, how it's written, show a demo of it. This webinar is about the core agents. We'll cover what exactly are the agents and how to build those agents. We'll cover some code around when we are building these agents. This webinar is also going to touch a live demo of an IPL kind of system. I'll explain and walk you through the code of it, of how agents work. What is the difference between the general large language model, a RAG system versus an agent? Because a lot of times we just get confused with it. In 2026, the trends which are going on. So I'm currently involved at a level where we are working in terms of figuring out a way to build an infinite context, a complete stateless system. And statefulness goes towards an entirely different scenario where we have layered scenario of how to handle context. So that's an interesting thing where I am thinking a lot about. A lot of companies are building MCPs. Thousands of MCPs are being built. So what is an MCP? Right now, when you're in the engineering phase, it's important that we understand that these things play a critical role, even if you're a non-technical person. And late 2024 it was introduced by Claude, then it was given to Linux Foundation. So yeah, how these MCP work now. So that was my answer for your what is this webinar about. Now, what's your profession? Okay, I am founder of CreateBytes. It's basically so I'm working in terms of building end-to-end platforms across the globe. It's a big team. We have different offices in Jaipur, Gurgaon, Bangalore, and in Gurgaon we have two offices. It's a big team working across the globe. We have an office in Bristol too. Then I'm founder of a company, Krigat. The name is Kriya plus Gati. Our current distribution market channel was UK, where we have built a personal trainer which does live exercises without any human involved. So you can get real-time feedback. So it's a pure computer vision-based system. Again, a patented technology. One more thing, if you guys want to understand how to file a patent, I've been doing it for a while, India and international. So you guys can know a lot about it. That's what Krigat is. And then Yugyog.ai. It's a CCTV camera surveillance. So also I'm currently involved heavily with Indian Defense. So working in the domain of logistics, supply management at software as a service scale scenario, and a lot of AI things which we do, prediction, recommendations, and also transformation. And if you talk about globally, where do we operate? US, Europe, UAE, Singapore, all these places. And I can also share my experience with how these countries and the things which are happening. So almost every month I'm here and there traveling. So I can give some insights around that too. If you want to know more about it, you can visit CreateBytes Instagram channel, CBX Instagram channel, or there's a channel with Aditya.ai. Perfect. Okay, Sunil. So that answers your question, Aditya, and like simple reflexive reinforcement agents and more. So we will be covering reaction agents, but I'll get into the detail later on. To give a quick idea, an AI agent is a system that uses a large language model. And it's important to understand in a very basic definition. You can have GPT, Claude, Gemini, or an OpenAI model as a reasoning engine to decide what actions to take, invoke tools to take those actions, observe the results, and repeat that loop until the goal has been achieved. So this is important. Whenever you are doing this activity, whether you take an action, invoke any kind of tool you want to, you can use MCPs for that. You observe the final results and repeat that loop again and again. A useful mental model, if you think of a capable, let's say, junior engineer. If you ask a chatbot, what's the revenue breakdown by region? It replies with whatever it was trained on and stops there. But an agent basically goes towards the direction of, let me query the analytics database, cross-check the CRM, reconcile the current currencies which are present and then convert them, and then write a summary about it. Like there are small tasks which are goal-oriented tasks which are given to different agents, and then finally you get the summary. So it plans, executes, and reasons about intermediate results. So the autonomous decision making loop, which is basically built with this thing, and where it's important to understand LLM is the brain, okay? And the MCPs, which are basically the integration, these are the tools which are in our hand, which we can use. This particular kind of system, which is separating it from the way conventionally LLMs were being used. It's important to understand why now. Like, what is the reason that there are so many things in AI which are going on? How do you ensure that you are basically able to get a skill? What skill? Learning fast. The very first thing is understanding the trends. If you get an idea about the trends, you can basically easily understand how things are going to evolve and what can come next. And that is the way we should be able to learn it. And this skill of learning fast can be groomed via understanding trends to a very large extent. This question, that is why agents matter now, it's important to understand why didn't this work 2 years back? Because LLMs used to exist at that time too. So the answer is there are different scenarios, okay, and which are basically reasons for it. Here in the slide, you can see the first reason, if you look at, is reasoning itself. Models like Claude Opus 4.7, GPT-5, Gemini 3, and others which have come out, and even like latest things which are happening with other models which are out of this, which is Quinn and all, they have finally become reliable to a very large extent, and they can do multi-step planning. That was not true in 2023, and it is very important. The other reason for this is the model context protocol, MCP. This model context protocol concept, it was launched in late 2024 by Anthropic, the thing which I was talking about, and then they donated it to the Linux Foundation in December 2025. That means, like, now we have thousands, like we have 10,000 plus public MCP servers available, model context protocol, and 97 million monthly SDK downloads as of the data of March 2026. In a very simple language, MCP is like your USB mount for AI tools. So you attach a USB, you mount a drive, that is MCP, that is it. Okay, and it is like a universal standard. So why everyone, like whether it is Mac, HP, everyone one is having USB C cable? Because it's a standard which has been built. So MCP helps you build that standardization, replacing thousands of custom integrations which people used to do earlier. Okay, that means we have a final business case which has come out in that direction. And third, which is again a very important reason, the business case with respect to utilization of it has started growing. Now, Gartner, guys, it's important to understand some of the facts which come on a regular basis, because again, these are part of trends and also some predictions and projections which come in. They are projecting that 40% of enterprise applications will have task specific AI agents by the end of 2026. Like in our company, Create Bytes, we are already doing a lot of marketing activities with the help of these MCPs. We are doing sales outreach with the help of agentic systems. Even that trend is something which we are also, you can consider us as part of an important life cycle of the company of us. And the important fact is we are basically going on a percentage by percentage basis at about 20 to 25% in terms of adaptation of these activities. Now, market is forecasting to grow from roughly $8 billion to over 50 billion by 2030. And it is important to understand, like, you're growing from $8 billion to over $50 billion by 2030. If I give you a very specific translation, the important part is people have started building skill and started using it with these. These are the three reasons which have basically taken us from the level where we were, where LLMs were not good, the context was not good, the business use cases were not being produced, and where we are right now. So it's important to get us an idea about it. So before I jump towards what is chatbot versus RAG agent, okay, MCP, I've explained it to you guys. Yeah, very nice. So you're transcribing the call. That's interesting. So let's pin down the three things people constantly confuse about, and it is important to understand. A chatbot answers from whatever the model already knows. It's training data. Ask ChatGPT capital of France. It returns Paris. End of story. A RAG system, which is retrieval augmented generation, first retrieves relevant chunks from your documents, then feeds them to the model as context before answering, and it is useful when the model wasn't trained on your ideas or your data. A support bot built on your product documentation is a classical RAG use case. When you want to retrieve something, an agent sits a level above both of them, above a chatbot and above a RAG agent. For an agent, these are just tools which it can use to do some activity. So it decides on a per step basis whether to use a retrieval system, whether to call a tool to send an email, to retrieve something, to fetch something, or run a calculation, search inside the web, or just answer. So it plans, it acts, and it iterates. And it is important. So like if you look at the orchestration, your chatbot, your rack system, all these are sitting like at a lower level. An agent is basically the one deciding what to use. So all these are ecosystem for the rack system. So a simple one line is, I want you to remember this one thing. A chatbot answers. RAG ensure that your answers are grounded, factually correct. A lot of times, in order to avoid hallucination of large language models, you try to rely on a RAG system, retrieval augmented. If you guys want to know about RAG, there's a video which has been already uploaded on YouTube, which you guys can check. It is containing like there are a couple of lectures, one basic RAG and there's an advanced RAG. And an agent is goal oriented, which ensures that the job is basically taken care in that direction. Now, I would like go towards what are the core components of an agent, and it is important to understand these core components. So every production agent has these four core components. Skip any one and quality degrades. Component one, which are tools. These are the agent's hands. Consider them as like hands of an agent. Okay. Web search, SQL execution, file input output, calculators, APIs. These are all agents. A Python sandbox. These are all hands like which you can use to do something. In 2026, because of MCP, tools are increasingly becoming like a plug and play system. Instead of some kind of hard coded or hand coded scenario to code something, it's like a plug and play. And that's what MCPs are. Like you can just consider in a simple language, model context protocol is just about putting a USB drive and mounting it with a standardization of type C. That's it, which every laptop, every computer can use. Okay. Component two is the reasoning engine, which is the LLM itself, which is the brain. This brain chooses what to do next, and then accordingly, you can have a concept of orchestrator agent, which orchestrates and then take different actions. Okay, that's the second thing, which is the brain of it. But the third, which I just talked about, is the orchestrator. This is the glue layer that manages tool invocation, state of that system, and the error handling. So when so many agents are working, it's important to understand a concept which is called as statefulness. So you need to know where we are now to proceed further. So it manages the state of where we are, accordingly do some decision making, figure out invocation of tools, and do a lot of error handling. So orchestrator agent is critical when you build a multi-agentic system. Okay, so again, three core components: tools. Number two is basically your reasoning engine, which is which LLM you want to use. And it is not like we have to use one single LLM for all the agents. You can switch. You can say that when I'm planning and executing, I would rather want to use Anthropic. But when I'm basically, let's say, doing something which is like very basic, a chat response, I'll use a Quinn model. So multi-agentic framework cost can be saved. And in the current era, it's important. Okay, one thing which I always say, guys, AI is not about just innovation, that I want to use AI to innovate something or build something. You need to mix the AI with innovation and ROI. Okay, return on your investment. Okay, so when you look at AI, always think about whether it is cost effective. Is there a mechanism to optimize the cost and then build something? And that's the important part here, that you don't need to be logged in with one single LLM while building this. Every agentic goal can be built with a specific LLM which is good for that. And you don't need to use a big, large LLM for everything. Okay, this is important to understand. Okay. And now, when it comes to orchestrator, which is the third component, it's important that a new term which I've talked about in our previous webinar was LangGraph. Okay, so there you have LangGraph, OpenAI has Agent SDK, Claude Agent also has the SDK, Pydantic AI is there, Mastra is there, Google ADK Live is there. All these are basically helping in terms of state management and orchestration. So we are going to go a little deeper into these. But again, the fourth component before we go in our next slides is important to understand, which is the memory. Very, very important. This is the place which talks about the scalability of a multi-agentic system. What you can do at scale is totally determined via the way memory is managed. So you have a concept, and which a lot of times we ignore. I'll tell you the reason, because LLM is being used. They have their own context. You can switch between them, but a lot of times it's something which should be considered when building multi-agentic. So short-term context for the current task, long-term storage for facts, summaries, and prior interactions are all long-term scenarios. Agents should be able to recall and figure out what happened. Okay, so these are basically important scenarios where you have very short-term context where it can take some action, move forward, but then there are some long-term context which basically can be built with embeddings too. Okay, which can figure out similar scenarios. It can have, let's say, some storage which is long term, which are like previous chats which have happened. If I'm having a conversation, it can figure out the previous conversation and see what can happen. So that's the idea. So these are the four essential components when you build a system with large language models and agentic mechanism. Now I'm going to jump towards a very important part here, which is like, how do you see a basic workflow in an agentic framework? So diagram is basically just a very basic code loop. Every agent, regardless of what framework it is using, okay, it can be LangGraph, even you can take Microsoft AutoGen as an example, implement some version of it. Okay, so step one is reasoning. The agent interprets the user's query and the current state. Step two, LLM processing. It asks the model, like, what should I do next? And then basically it jumps towards the step three, which is basically tool selection. The model picks the right tool, web search, calculator, database query, API call, and then step four, which is operation execution. The selected tool actually runs that. Okay. And then step five is result observation. The output is fed back to the model for evaluation. And then we jump towards the sixth step, which is the next action guidance. Based on the observation, the agent either continues or branches to a different scenario or terminates. And this whole thing is goal oriented, guys. We need to understand its important part. Every agent is goal oriented. And that is one basic difference between how a workflow is defined, which is very process oriented, and how agent is defined, which is like to reach a particular goal. Okay. In a, like, let's say a technical terminology, you can call it as react pattern. Reasoning plus acting, react pattern. And there's a paper, guys, which I think it's also present in the GitHub repository, which is from Yao, and the paper talks about how the React patterns behave, and this was taken from there only. The slide. So you have LangGraph, OpenAI, Agentic SDK, all these are just abstractions in terms of utilization, but the underlying layer is basically this basic workflow. And I hope you understand it. So the diagram is basically something which gave a brief about how it works. But now we are going to jump towards a concept which is action agents versus plan and execute agents. And important to understand the difference. So there are two dominant agentic architectures, guys. Action agent decide one step at a time in a reactive fashion. Fast, cost effective, and very simple. Perfect for queries like what's the weather in Bangalore? One tool call, one answer, plan and execute agent, build a complex plan first and then execute each step. Better for, let's say, very simplistic scenarios. If we look at 2026 best practices with Action Agent, we'll be able to see a lot of such products have been built in that direction. Only reach for plan and execute when task is genuinely requiring upfront planning. Only then go for this kind of agent, which is action agent. And this is where we as engineers, our decision making come into the picture, because plan and execute adds latency. It's always about like every time it has to plan and execute, it is not a good idea that we use it everywhere. It also multiplies the number of API calls. So for example, if I know audio agent, and every time I use plan and execute, is it a good idea when you're working with audio? Is it a good idea for the other person to wait for a long duration of time every time because we have a plan and execute happening? No. So that's why we have the other patterns which are like faster, where you do not need to do this every time. So LangGraph support both the patterns natively. Crew AI learns towards plan and execute through its role-based crews. Okay, so Crew AI is also something which you guys can look at. Similarly, we have OpenAI agents, SDK, which uses explicit handoff between specialized agents and let's say any kind of custom scenarios which we want to build towards. And that's one thing which we need to understand at a very high level. When the question is, when should we be using the agents? Because a lot of times the typical over engineering happens. I just start building something up, okay, without thinking, oh wow, this is something which we need to do. There is AI involved. Let's do it agentic. Why? Do we need to build everything agentic? No, not at all. Okay, so and this is something which I've seen as a trend in engineers because they know something they have implemented. No, so the single biggest production failure in 2025 was teams building agents for problems that didn't need them. Use an agent when one prompt isn't enough, external tools are required, and the task has multiple steps. You need search, retrieval, or computation, and the system must adapt based on intermediate results. Don't use an agent when a straight prompt or a single large language model call will be sufficient to take care of the things, where the workflow is very fixed and it is deterministic. No tools are used in terms of doing any kind of brain activity, and the task can be handled by a traditional script or a scheduled job. Okay, like this is very critical to know when not to use it. Okay, and that is why I had an explicit slide for it, talking about when we shouldn't be using an agent. Now let's think about the practical use cases in terms of using agent. The question to you before I jump there, what do you think at a very high level, where the overall scenario has a practical use case? And I have listed down some, but I just want to check with all of you. Are you doing something with agentic thing? Ask this, that yeah, can I use this for agent? I'll tell you yes or no and why. Okay, let's do this exercise so that I know for sure that you guys have understood. So we know about research agent, document Q&A, production support scenarios. I am using agentic system for a lot of activities where, let's say, context is involved. We are basically using it for training purposes, in terms of AI trainers coming in the picture. CCTV camera analysis is being done with agents. But if you have any case, I can tell you like whether you should be using agent or some other thing. Then we'll jump towards the next slide, which is research agent. So I'll quickly jump towards the use case of research agent. Okay, and we'll get into the detail of how a research agent works. And these things will help you understand how to build agents too. So what is the problem? A user needs an answer that requires synthesizing multiple sources or information which is more recent than the model's training cutoff. So agent solution is it plans the research, invokes the search tool, retrieve and process the results, and synthesizes a grounded response with citations. To give you some real example, let's say I'm doing a competitive research for a product of mine. Okay, then I'll have pricing, funding, team size, product positioning across, let's say, different startups, produced a comparison table, which is like a 10-minute scenario which I need to build. And then once when I'm doing this, all these are research agent perspective scenarios. Okay, now if I look at the AI regulation overview, when I'm doing these activities, it's important to understand the policies in India, European Union, US with the links there. Okay, where events or companies do a very good research. Okay, which are with respect to who are going to be the speakers, who are going to be the what is going to be the agenda, like Impact AI Summit which happened. So all these things need to be done. Can instead of a human and agent do it? If we build a right orchestration, it can be taken care even in that direction. And there are a lot of tools, I mean, large language models, which we use with chat, but there can be an autonomous scenario too. You would have used Perplexity, ChatGPT, Gemini, but you can do the same activity with the help of a typical agentic framework, which can take just 15 minutes because the repository which I created is completely agentic, which is the IPL, which I'll show you. And it took me less than 20 minutes to build that. So one thing which we will be learning is we can build agentic systems very fast, and I'm talking about literally 30 minutes. I'm building very big repository, guys, with within 1 hour, 2 hour kind of thing. And when I'm doing it, if you know the system and you are the intent driver, you can do it much more faster. The only thing needed for you to build a repository which works in production in 3 hours, which is a good one, a small project, is understand the concepts which are basically underlying of how to build those things. Okay, once you know that, these can be done at a very fast pace. And I'll quickly jump towards the Q&A and research agent, okay, which is again a very simple thing. So the example use case, you can take LangChain's classic React agent with, let's say, fake list of large language models. Okay, again, LangChain, LangGraph, I've talked about it before. You guys should look into how these work. And maybe if you have any question, I can cover that at the end of the call. So, but let's say a mock large language model that returns predefined responses. So the whole thing runs without an API key. The code uses LangChain system, which I'll show you right now. So let's jump towards the code also and give you an idea of how it is built. So you can see that the overall scenario is where LangGraph is basically a newer thing as compared to the LangChains scenarios, where you have graph-based agentic libraries present there. For state management, you can load tools with those agents, and LangGraph helps in terms of maintaining the state of these things. Now, if you see what it is doing, it's basically a fake Google search function, which is a simple Python function that takes a query and returns a canned answer. That's it. Okay. In production, you would like to do a real search, which you can do with Serper API and others which are available. Even a Bravo search is available. But the function is wrapped in a tool object with three pieces: a name, the function, and most importantly, a description. The agent reads the description to decide when to use this tool. Writing tool description is now like a very, very, very important skill. And again, it is part of the skill, it is part of the way it need to be written. So again, this is important. You guys should use this as an example. Okay. The industry calls it as part of context engineering. Okay, where you define these things. And again, these can be short term and long term context depending upon how you are using it. Like what it is doing, it a very vague description can be search the web. It will cause the agent to pick this tool incorrectly if you just write search the web. A specific description like searches the public web for current events and general knowledge, do not use for internal company data, will produce dramatically better results, guys. Again, this is a little different from a typical prompt engineering scenario, but tool description is again an important activity. The second tool, if you see, is LMath, is LangChain's built-in calculator. The agent follows the same re and act, which is React template, okay, which is question, thought, action, action input, observation, and repeat until you get the final answer. And that is how it works in this example. Okay, now if you see, there is a final wiring to it, which is given, okay, which is the last scenario, which is create React agent, combines the large language model, the tools, and the React prompt template together. Okay, and then agent executor wraps it with the execution loop. The critical parameter, if you look at here, is max iterations. Without it, an agent can loop indefinitely. And this is important to understand, the max iterations. A lot of times when we are building it, we just ignore this part. And if you guys are practically doing it, you would have faced an issue with this. So nothing burns, a, like you need to think from the perspective of what I've mentioned earlier, innovation plus ROI. So the kind of billing we can get with Anthropic API keys used. One of the videos which I put is like companies are paying 100K or 200K. Like the thing which we used to pay to the cloud, which was rare, we are paying much more bigger amount to these LLMs. And you can save it if you are able to work it in a very intelligent manner. Now in production, there are other things like Langsmith, Langfuse, Pydantic, Lockfire, and all, which you should be adding in terms of building it. But this is more of like how you should be building it. Now, it's important to understand that how it actually ran. It read it through top and bottom. It analyzed it with its brain. I need to find the number of goals scored in the 2018 World Cup. And then the action was Google search. And the input was number of goals scored in football, or let's say cricket, you can take an example, or any sport, okay, in 2018. I don't think so there was a World Cup of cricket, but yeah, give an example of taking a sport and then searching for it. What was the observation in football, for example? 169 goals scored. Then it thought, now I need to add 1,000 using the calculator. Then it took the action as an input and it said 1,000 plus 169. And then there is, if you see, there's a small hiccup which can come in, which is the tool naming inconsistency. But because there was an issue, it recovered from it and then figured out the answer. Because it was goal oriented, it was not deterministic or path deterministic, it can figure out an answer. Okay. So now we need to understand when and how we should be using it. But guys, it's important that we understand this aspect in a very clear manner. Okay. Now you can see how it basically performed it. And then we'll jump towards a very, very concluding fact of what we have seen from the code. I'll just try to take the function name. So if you look at it, which is fake Google search function, then you have fake Google search tool. It's basically doing description, which I talked about, and then it is taking action, and then finally you have an outcome. So it is basically thinking. And then you can say that agent can just write what they are doing or what they are thinking, and that's how you build it in that fashion. Okay. So I'm gonna go towards what exactly are the four takeaways. Number one, agent decompose big questions into traceable sub problems. Very important, guys. Number two, they rely on external tool and not the model's frozen memory. They process and reason over returned information before answering. And number four, this exact loop scales bigger, bigger, bigger. Okay. And this is important to understand how it happens. Okay. And when you are doing it, that means you can think about a lot of similar use cases once you know how they are working and what they are doing. Okay. So again, jumping towards the next big thing, why RAG matters for agents. Okay. And now I've given a detailed lecture about different kind of RAG in our company. So currently, guys, we are working across the globe. Like we are building very, very big agentic systems, and we're using RAG for medical production ready systems. We are using RAG for fintech systems, transaction fraudulent scenarios in UK. So we are doing it at a huge scale. And we have seen an evolution with very close eyes, and we have done our own activity in terms of how to build RAGs. And you have RAGs which are like they started with an embedding search, then they have graph based system, then you have agentic RAG, then you have adaptive agentic graph RAGs. Like that's the evolution. Now why it matters for the agent, because one of the most important thing, guys, is large language models dependency can create hallucination. If you want your answers to be grounded for some critical aspect, you should have RAG agent sitting and answering some factual answers. So that's why they become very, 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 very critical and important, guys. Okay. Now, if you look at the RAG agent architecture at a very overall level, you basically, what do? You do chunking of, so you have a big text, guys. Then you chunk it. And now in chunking also, there are so many algorithms and strategies. Like you can do adaptive chunking. A chunking concept need to know what were the things which you talked previously and after, so that you have the right embedding, and then embedding similarity works in the right direction. So first you do chunking, you do indexing, then you create a vector store to save those chunks. Then plus additionally, you can use that to create graphs from that chunk, knowledge graphs. Aditya lives in Delhi. Okay, so is a subject, lives is a predicate, Delhi is an object. When you have this, you basically create a triple, and that basically create an entire knowledge graph, which can be used to factually trace data much more accurately and much more faster. Okay, then you do retrieval, query generation, then you have agentic system which are using it, and then finally you can get grounded responses if you use these. Okay, now one thing for sure, with whenever like you would have also seen, when we talk about, oh, there are multiple documents and I need to ask some questions and get an answer, that's a direct use case of RAG. You can have legal documents, medical documents, so many things. And then there are so many interesting activities happening on top of it. People are integrating it with your Google Drive. Like some people are working even at let's say I think you guys should know about it, but I'll just term it Google file systems. which it got introduced in a paper in 2003, GFS. Then HDFS came in, Hadoop Distributed File System Architecture. Then Linux system used Chef file system, which is like on your system. Now there'll be a scenario where Chef will evolve into a very powerful file system, which is much more powerful in terms of document searching and chat, which may become part of your operating system by default. Okay, so that's how the even the documentation evolution is happening. So all these things are going to come with RAG and the use cases which can come around this. Now again, let's understand Llama Index and style agent workflows, like how these work with. So what is this Llama Index? Okay, guys. So Llama Index popularized a pattern called the router agent, and important to understand because from the term I've explained it in past, but from just the term, always remember index is always indexing is like figuring things out faster. So then Llama Index popularized this thing which is like the router agent, and it's cleaner than it sounds. Okay, like you're thinking that what is this lang chain, LangGraph, and then there's this Llama. All these are very interrelated and very, very simple as compared to how they are. So what is step one? Build separate indexes for separate data sources. One index for HR docs, one for sales, one for engineering. And then in the second step, wrap each index query engine as a tool with clear description. This tool answers HR questions. This tool answers sales questions. And then in the third step, give the agent all these tools. Okay, that HR question thing will be this tool. So give the agent an access to it, give the agent. So what you have done, you have basically first indexed it, then it basically figured out, okay, I can check for HR, engineering, sales, everything. And then it reads the user's query, matches it to the right tool based on the description, and routes accordingly. And this is very critical thing. So step 4 is the selected query engine retrieves and grounds the answer. And this pattern is scalable, distributed, and it always goes in the right direction. Okay, because it is easy to reason, easy to debug, and it scales linearly in the right direction for us. Okay, every time I add a new data set, I'll have a new tool to it. And you can implement the same pattern in LangGraph through AI, OpenAI Agent SDK, and other multi-agentic framework. Okay, so again, these 4 things. This is Llama Index style agentic flow. Guys, remember it and use it. Very, very critical. Okay, it is related to building a routing agent which can route data from different places and go towards different direction. And this is like to give you an example, you have a report generation use case. You want some kind of structured report. Then you have planning execution. So you have AI regulatory overview, country analysis. There are weekly trends which can come in. Then you have a final market report. All these things, plus the report contain different directions. Like there can be a scenario for HR related data needed, sales related data needed, engineering related data, and you can combine that. Okay, so that's why it is important. Now, let's jump towards an important thing: planner and executioner. Both of them should be separated. Guys, I'll tell you an interesting fact, which is how we are coding. Okay, and it's an interesting story. So first, I want to understand: are you guys coding in AI? Are you guys coding in agentic scenario? Are you involved there right now? Anyone who is doing agentic coding right now? Or maybe just vibe coding. Anyone who's doing it? Okay, no manual coding. Perfect, perfect. This is a perfect yes. Okay, so I have one question. Which LLM are you using for coding right now? Anthropic, OpenAI. Okay, you're doing vibe coding. Are you using some LLM for doing it, like Cursor with some LLM or anything like that? Or some secret key being used with LLM? Okay, Claude, you're using. So, guys, it is important to understand. And again, this brings back to my point: AI is equal to innovation plus ROI. Okay, codex you're using. So, see, these are all huge models. Anthropic is the costliest model. Then you have Opus, then you have basically the other model Sonnet, which is present with Anthropic. Then you have OpenAI Codex. But do you guys really need Anthropic to code, or do you really need Codex to code for you? Think about it. And that's where this planning and execution thing comes in, guys. If you build a structured agentic orchestrator in terms of your coding capability, you can save millions of dollars at enterprise level. And at your level, you can save probably hundreds of dollars or thousands of dollars. Okay, so there are a couple of things which I'll talk about. So the concept is, when you are planning, let's say you want to build uh, an IPL match summary system which talks about who will win the orange cap, what will happen there, what happened in past. So like if you want to build a code base for it and a RAG system for it, you do your planning, a detailed planning with an implementation plan, story grooming activity with Anthropic. That's it. So use that for Anthropic or Claude, or you can use Codex. Then when it comes to executing the code, because the planning is so detailed with each agent what it should be doing if you've done it, and I can share prompts of how to do it, and like even a container of how to build this entire thing. The execution is taken care via a very let's say a lower model of Claude, which is Sonnet, or let's say you can use Codex lower version, or even you can use Quen or other models. So the execution doesn't need the same large language model as Planner, so that's why it's important to distinguish. And then you can do your code review with a smaller model. You can do, after that you can do, let's say write unit test cases, integration tests with some other model. If you do this, you can actually save 70 to 80% of your actual cost and build large systems. So do not use the same large language model for everything, guys. But again, that can only happen if you understand the core concepts, so that your planning phase become much more important and your execution basically can be taken care in different models. So again, that's why in this era, we focus a lot on planning. We decide the strategy, break the goal into steps, improve structure. Did you guys understand? Oh, so using Lovable to create applications, that's a good thing. So Lovable behind the scene can be optimizing it. Okay, but it's like you don't sometimes even need Lovable in that direction. There are now much more powerful ways to do those activities. But yeah, for some scenarios you can use Lovable. But I recommend to you, Sashi, that you explore the other agentic systems, because this age is all about learning fast and improving from different directions and utilizing as many different tools and things which you need. Like, I'll tell you one more thing. Do you know who is Andre Karpathy? Do you guys know who is Andre Karpathy? Oh, Claude, good, nice. Do you guys know who is Andre Karpathy? No. You guys should search about him. He tweeted something, and so one of the things which happens with Claude, guys, if you're using, let's say, Claude Code specifically, or OpenAI, okay. Every time, in even in Lovable, Shashi, every time you code, the entire file basically go towards coding activity every time. Like you want to do something, if there are thousands of files, they have to trace and parse everything. But you can actually generate a knowledge graph of your code, and as per this GitHub repository, and it is just 1 week that it has come out, 71.5% token reduction, guys. If you're coding at that level, 71.5% token reduction if you have built a knowledge graph locally of your code, and you just install that library, tell it to run a knowledge graph, and then your Cloud Code may be reviewing it. So that's interesting. But again, so that's why planning is important and execution has its own importance and should be done independently. And now I'm going to jump why memory matters in AI agents. Okay, so two foundational references. AutoGPT, which was released in early 2023, introduced the pattern of an autonomous agent using external memory to assess context, formulate tasks, update a task queue, and continue until goals were met. It captured public imagination like few projects before it. And this is important to know. Generative agents from Stanford's 2023 research paper introduced memory streams scored by importance, reflections generated from past experience, and retrieval weighted by relevance created this whole scenario. And we need to understand, in 2026, AutoGPT is not what you build with today. It was the proof of concept that motivated everything else. Modern production systems are built with LangGraph checkpointing, which are like states being maintained every here and there. We use masterclass for memory system, creates built-in memory and all these things. But the conceptual DNA, which is autonomous task decomposition, external memory, and then reflection towards it, is everywhere. Again, I'll say this, three words: autonomous task decomposition, external memory to save something, and then reflection on top of it is being used everywhere. And that's where memory is important. You need to have a short-term memory, which is current context window, and then you need to have a long-term memory, which is like vector storage, files, which can be accessed and used for a lot of other purposes, guys. Okay, and this concept, guys, this do not take this lightly, because the next research, 2026, from this month to December, you will see a very, very fast evolution in this space. I am also involved in this research at my end at global level, and I'll tell you, this is one of the most interesting phase in this, because we are trying to find a way to get to the best memory optimized mechanisms possible across the globe. So this is important. Now, I'll jump towards tools and function calling. But before that, you guys need to know this concept where you have autonomous mechanism of task decomposition. Then you basically take that task, complete it, and then store it in some external system, and then you try to react to it. Okay. And then quickly we jump towards this concept of tools. So you have search tool, calculator, file read write operations, retrieval tools, custom functions, Python execution. All these are tools which basically are used for a lot of purposes. So this basically correspond to the concept which we just discussed, which is MCP servers. MCP is an open standard that lets any MCP compatible agent use any MCP server across any framework, across any model, and build your tool with MCP. And if you've done that, you can basically work with Cloud Desktop, Cursor, Windsurf, anything. Guys, important to understand. And then categories, if you look at web search, calculators, file input output, retrieval, custom business function, any kind of email, read, email, write, anything, are all these things which basically correspond to MCP. Okay. And 2026, basically there's a big shift, and there's a public accessibility and usage with model context protocol. Again, open standard that lets any MCP compatible agent. So there is MCP server, and then there is MCP agent. So it's like an open standard that let any MCP compatible agent use any MCP server across any framework, across any model. It's similar to, again, I say USB-C drive, which is compatible with across any laptop, across any desktop. And if it is compatible to that, it basically just plugs in and being played. Now, this number as of March was 10,000 public MCP servers, 97 million monthly SDK downloads, and then having a native support with Claude, AWS, Microsoft Copilot Studios, everything. And that's the important of it. Okay. And then we'll jump towards a custom function calling example, which allow the model to identify which function to use and what arguments to pass. Okay. And then like if we just quickly jump towards the, like, I'll not go towards it because you guys understand like how custom function works. And let's say I'm building something which is like OpenAI assistant built with these capabilities for us. So the open, like if you look at the core original one, where you had OpenAI API, which was shipped with three capabilities: code interpreter for Python execution and sandboxes, knowledge retriever for uploaded documents like RAG, and function calls for custom tools. 2026, this picture of OpenAI has become much more broader. It now offers like agent SDK and response APIs. And guys, I'm using it right now. It's very smooth. Okay. Which are very flexible and better suitable for production. And I'm using OpenAI Agent SDK, and I'm doing a lot of interesting activities with it. And guys, well, it makes your life so much easier. It helps you build agents at such a fast pace. And same thing. And through also ship the Claude Agentic SDK with native MCP support, extended thinking, computer use capabilities, and all these things. Google also has the Agent Development Kit, which they call ADK. It is optimized for Gemini with native A2A support. Okay, Microsoft has consolidated this entire thing into AutoGen. So all the big players are using these things. And that's why it's important to understand and maybe practically use it. Similar, I mean, comparable in terms of how easy it is to use and distribute on your own at your own pace. Now, what is this auto GPT, guys? It deserves like an important attention in our current slide. Reason being, it got released in March 2023. It was the first viral autonomous agent, and that is why. Remember it. What I said earlier, remember the trends, remember how it evolved. So it gave itself prompts, decomposed tasks, assessed the internet, wrote files, and continued until goals were reached. It reached over 170,000 GitHub stars. And for a very small period of time, people started debating about AGI when this came out. They thought, oh, if you guys remember, there was a thing where AGI has come out, because they thought that if this is there, this is the AGI. But the when it goes to production, the reality was much more harsher because they thought that they can use it in production. AutoG got stuck in reasoning loops, burned the APIs, caused a lot of cost for companies, and it struggled with reliability. And no serious big enterprise was able to ship something which was useful with it at scale. Okay, so it's important. But the concept, autonomous decomposition, external memory, the usage of tools, and long horizon execution. This is the basis of our current multi agentic framework, guys. So that's why it's important to know how it evolved. And then we come towards the multi-agent system, which is like the next level of it. So multi-specialized agents collaborating with one another. Use case, let's say expert collaboration. One agent for finance, one for legal, one for compliance, coding plus domain expert pairings. Simulations are being running there. Distributed research terms where agents split the sections. All these basically working together create a multi-agentic system where you have multiple agents, orchestrator agent, drafting agent, copy agent. We have built a very powerful sales orchestrator agent which can do responses, can outreach to our potential customers, grow at its own. So we are creating one of the most powerful distributed. So in this AI world, guys, it's not about, okay, I'll do a prediction today. Okay, I'm gonna do a prediction. Eventually, softwares, and listen to it carefully, eventually, softwares will become like your Instagram feeds, like your videos, like your text, yeah, like your blog, where you just have so many of it. Like it's like a social media when you're scrolling the videos, softwares will become like that. The middle layer, which used to thrive on building products, that thing will eventually become like so easy that it's like an Instagram feed of videos for you. So when you have something like that, the important aspect is how do you distribute? So you don't need to think now that I have to build something, but you need to always go towards, can I create an impact and ROI? People will not give you money to build something. People will give you money for the impact which you are going to provide with that, and how you distribute, and do you have the distribution channel control over it. So you need to evolve yourself, and this is something which I am predicting today, and you guys should know about it. Okay, and you guys should, like, if you have any questions, how it is going to happen, I can even give you a step-by-step direction of how a software will eventually become so much commoditized, a software becoming so much commoditized that it will be similar to an Instagram story, or a small blog or tweet. And so, guys, it's important for you to know that this is going to happen. Okay, I'm gonna. Any questions? Anything which you want to know? So, as I'm currently in computer engineering field, how can I move towards AI as it will be needed? Okay, I'm gonna answer this question in few minutes. First, I want you to ask me questions with respect to the current system. Any questions on this so far? And then I'll jump towards this question for you. Anyone? No? Okay, I'm gonna proceed further and jump towards the last section. Okay, so two research projects which we should know about are Camel. It was from 2023. It introduced role-playing multi-agent collaboration. Two agents with distinct personas working towards a shared task with minimum human oversight. A classic example was stock trader agent paired with Python programmer agent, building a trading bot together. Very interesting. So 2026, it basically got into this scenario of role-based crews. Generative agents from Stanford's 2023 paper gave agents memory streams scored by importance, reflective reasoning over past experiences, and retrieval weighted by relevance importance. And this is important. And that's why statefulness goes in the right direction. And camel is a very, very interesting way of looking at things of how the past scenarios were happening. Now, there are a lot of risk and failures in this. Infinite or wasteful loops, false completion of tasks, high latency cost and long workflows, too broad general agents becoming ineffective, need for clear stepping criteria and control. And I strongly recommend a mechanism of measurement and benchmarking is also important while working with multi-agentic framework, guys. Okay, now, like, what are the best practices, guys? There's a checklist. Okay, number one, start with a narrow use case. Specialization beats generality in production. Always remember. Number two, minimize your tool set. Every additional tool widens the action space and degrades the tool selection accuracy. Third is use the retrieval for factually grounded data so that hallucination drop meaningfully and we can literally use it in production. Fourth is add memory only when the workflow actually needs it. Don't default to stateful even if it doesn't need memory. Fifth is define stop conditions very explicitly when it should stop doing because otherwise it can go in loop. So max iterations, token budget, time budget, success criteria, all these should be defined. Number six, which is log everything. Like for example, tool calls, LLM responses, intermediate state, final outcome. Without the logs, debugging agent is effectively just impossible, guys. Now this is more important. We always used to talk about software as a service logging. Here it becomes more important. And number seven, prefer specialized agents over broad autonomous agents. And in 2026, we can basically build and evaluate harness before the agent. Guys, this has just come now and you guys should know harness. Build your evaluation harness before the agent. Remember this. Okay. And I'll share a code base of how to do that. And you'll see a lot of Instagram influencer videos talking about harness. Just go out and see. On your Instagram, people will be talking about harness now, not earlier. Now they'll be talking about it. But this is a new thing which has come out. Okay. So now I would love for you to build research agents for market competitive analysis, document Q&A, product support assistant, report generation, simple planner. Guys, I would want you to build it, share the portfolio, do the review. There's a high possibility we are looking for interesting folks to in our company and a lot of our clients. If we see that any of you are good at and are doing these lectures regularly, there's a high chance that one of the hirings can be from even you guys too. But yeah, do look up and check what we are doing. And guys, scan the code. Once you basically register on Instagram or you follow it, you'll be able to get into a WhatsApp community where there are a lot of GitHub repositories, portfolios which are being shared. A lot of interesting activities will be happening moving forward. And yeah, you guys can scan. I'm gonna wait for 30 seconds or 1 minute here. Um, Sarthak, Achal, guys, we can switch on the audio video. I would love to interact with you guys. If you have any questions, I would love to answer it, answer your follow-up questions. Yeah, guys, over to you. The floor is yours now. And then we'll jump towards the demo. Okay. So now in case of multi-agentic orchestration, so Santhan, you were asking with very high control on agent to agent communication along with production logging metrics and trace over each agent, which framework to choose, like Crew AI or LangChain or LangGraph, or enterprise level frameworks like Google ADK, when to use which to fully working workflow with multi-agent? Very good question, Satya. Okay, I'll answer this. First thing you guys should understand, every open source, so first there's a differentiation. There are some open source ones and there are basically some which have to be paid. So when it comes to using it, let's say if I have some Google Cloud credits and I know that I want to do these activities and I have a simple orchestration, I don't need a lot of control over it. Okay, I should just use Google AD with Google credits, because a lot of times it's important. And I always say it, when you are in a startup, you want to build and scale faster. You don't need to start from scratch. Correct? So if you don't want to start from scratch and you don't want to maintain infrastructure, start using it at scale. Okay. So Google ADK is something which you can use. But for example, me personally, I've been doing it for a long time. I use LangGraph. I use LangGraph, Llama Index, Langsmith, LangChain, all these things. So I do use this a lot. I in like 1 year back, I was very interested around Microsoft AutoGen and using it, how it is. But yeah, like it highly depends upon your use case. But definitely LangGraph is something which is quite scalable and you can use it. Crua is also very popular, frankly. So you can use that too. But it's important to understand, like when you decide for something, okay, you guys should look at one of the video where if somebody comes up to me and talk about the problem statement, I will not jump towards solutioning. I will first draw a system context view, system component view, break the problem into what is the input, what is the output, what are the constraints. These things will help me decide which tech stack to use. And the same thing applies here. So once I know that in my system architecture, I'm not using Google, everything is built with Microsoft, and I'm using Active Requirement Enterprise Solution, then I'll think about, okay, maybe Microsoft AutoGen or maybe LangGraph. And if my team is bigger, I know my infra team can maintain things, can continuously have a CI/CD pipeline, everything, then definitely I'll use LangGraph because I have a team. But if I'm an individual, just want to build something, scale it immediately, I'll use AutoGen or Google AD. It also now comes towards memory context capability. So one benchmarking which you can always look for is if your agent requires a lot of memory and you have long executional durable activities going on, which agent works good with memory? Because one differentiation which you can consider among all these multi-agent framework is memory wise. Some of them have evolved, some of them are still going on. So that's important. Yeah. So Anusha, these slides will be shared soon. Probably by tomorrow. In the Google community too, on the YouTube video will come out, plus also on this thing. What do we call it? In the GitHub repository too. It will come. Claude Code versus Copilot. Same or different? When to use what? Claude Code, bro. Any day, Claude Code. No doubts, no questions about it. Claude Code is quite powerful. But your right question should be Claude Code or Open Code or Cursor. Okay, Copilot, I won't consider it strong enough at this point of time. That a lot of things which are gaps which it need to evolve with. But I would rather say Claude Code versus Open Code versus this. So Claude Code definitely costly, like because I'm building production systems and I need to think about it a lot and deliver it faster. I've built very efficient pipelines in my system and I use that. But at the same time, I use Cursor too. But the way I use it is I build Claude.md, I use skills while coding, I use implementation plan, I ensure that I'm not overspending on coding and execution because that's an easier task as compared to planning and distribution. So you need to make sure that that happens. Any other question, guys? Guys, your mic is open. Achal, can we open the mic and this thing so that team can ask follow-up questions if they have any? Or guys, you can let me know. Like, yes, it is open. Guys, you can even use mic to ask me questions if it is easier for you. Anyone? Okay, perfect. So done. So we can close it for now, and I'm gonna quickly see if I can give a live demonstration of an agentic system for you and help you understand this thing at an end-to-end level. Just give me a sec. Okay, I'm gonna show you how the coding can happen. Aditya's question was, I am currently in computer engineering field and how I can improve towards AI as it will be the need. Okay, so I'll answer it from here, guys. If you have time, scan the code. Just get inside the Instagram community and the WhatsApp community. But yeah, so question is community field and how can I move towards AI? See, number one, computer engineering field. First thing, how can I move toward AI? So do not consider AI as कोई direction है. साथ में एक second capability augment करनी होगी bro. मतलब meaning, for example, if I'm in college, ये generation का जो college students है, important to understand, यार, either I am good with ICs, which is integrated chips, semiconductor design, robotics, drone tech, and then I augment that with some of the AI. So whatever you're doing, you have to have AI with it. It's like English moving forward. Okay, so you need to basically learn AI, understand it, but at the same time, in college, try to add a couple of more things with that. Either you get inside a portfolio where you know robot building activities, ROS framework, architecture. AI engineers need to get and become intent drivers and become system engineers they need to learn a lot about how the systems are. For example, in our time, we used to learn about how to build, let's say, scalable REST APIs, how to build systems which basically can have OAuth 2.0, have token-based scenarios, security and other aspects. Now, in the AI world, these things can be done by AI agents, but I know the system, then I can take some important calls. But like in college, I strongly recommend, because this is going to be the trend from 2026 to 2032 in India. And I think you guys can get very, very interesting things in India itself. Don't need to look out or go outside India for doing this. Simple enough, get full detailed understanding, build a portfolio with some robotic thing, semiconductor design thing, some kind of AI. So लर्निंग एआई का मूविंग टुवर्ड्स सिंपल सा है, एक प्रैक्टिकल इम्प्लीमेंटेशन, दैट इज इट. प्रैक्टिकली इम्प्लीमेंटेड, डू समथिंग विद इट, पोर्टफोलियो बिल्ड कर. एंड आई ऑलवेज से दिस, फेल पास्ट थ्योरी में इंपॉर्टेंट चीज ट्रेंड्स, हाउ द ट्रेंड इज गोइंग, पास्ट ट्रेंड से क्या हुआ, उससे काफी चीजें लर्न करने को मिली और इंटरेस्ट भी. ओके, परफेक्ट. एनी अदर क्वेश्चन गाइस? इंटीग्रेशन ऑफ एआई, integration of AI. What's the question? I didn't understand the question. Okay, thank you. Okay, I'll samajh gaye. Okay, nice. So, guys, so this is the code base. Can you all see the code? This is in cursor. Do you know cursor? Who all know cursor, guys? Hand raise. Yes, yes, I know. You just need to install cursor. Okay. No. Okay, you guys. Okay. Okay. So let me. So this is cursor, guys. Very powerful thing. Okay. This is a GitHub repository, and you have documents like this. Is a doc which I created for you to understand what this product is about. The IPL 2026 agent is a Streamlit-based assistant designed for webinar. This cricket-specific Q&A and live demo narrative. Okay, so it's a cricket-specific Q&A which has been designed, and it has multiple things. So I'm going to jump towards what the product can do. What are the core capability? This is an MD file, guys. Fixture lookup by data phrase, supports prompts like who is playing today, who played yesterday, matches on 2026, 2025, handles relative date phrases. Team overview, returns team profile, captain, coach, squad list, upcoming fixtures and recent results. Player comparison, compare two resolved players using available season indication from local data. Builds preview context for two teams. Let's say leadership players, there's this live demo snapshot panel, all these things. And the UX community, agentic framework use. The system is implementing LangGraph based system. I'm going to quickly jump here. I can go now. What is the, let's say, who played today? So who is playing today? If this question, agent steps. So now there are no IPL matches. So agent execution plan created. First, it's a primary route fixture lookup with plan. So it checked for if there is a thing. Then tools which were executed. Fixture lookup tool loaded the IPL 26 fixture list the 26 April 19. Evidence checked, which is RAG. All planned evidence collected. Response prepared. Final answer written with the deterministic template. Okay, let's say preview RCB and this and this. So then primary, and then what it did, it basically Lucknow Super Giants versus Royal Challenger Bangalore. The match is listed at Chinnaswamy Stadium. On this, LSG are led by Rishabh Pant and RCB are led by Rajat Patidar. Players to watch from 26. Team info, Lucknow LSG team profile, captain, coach, home ground, squad size, full squad, upcoming fixtures, primary route, match preview with this, then tools which were executed, evidence check. So this is like an agentic framework. Show the full squad of RCB. Okay, then it basically shows the squad and the other details. What? Yeah, somebody is asking a question. I'm gonna quickly jump towards that. Time mention nahi. Time mention nahi for what? You mean the product? Yeah, it's fine. It's more of like for your demo understand. So this is agent.py file, guys. Okay, so agent state, query, route, plan routes, plan nodes, plan attempt, critique, tool payload. So like the way I should look at it is, I should basically quickly jump towards the script size, check for refresh live snapshot. I should first check the data loader.py and tools, but first agent.py, IPL agent. So this is the class of IPL agent where I define demo data, tools, live demo snapshot, live demo scenarios and all, then build the graph. So it builds a graph for me where I add a node. So this is LangGraph, guys. Okay. So this is a literal LangGraph example which you can understand, and that's how you build a graph. So in a graph, you have nodes and edges. So it is adding a node as a planner node, adding a node as tool execution node, adding a node as critic node, adding a node as analyst node. What is an agent? Edge. Edge is like planner edge, tool executor edge, critic edge, analyst edge. So every node is connected via edges and they can intercommunicate with each other. Then you run the route, the answer, the sources, the steps, tool payload, tool this. And then you plan a query. Query you can plan and write and get an answer from that. Then you run tools. What are these tools? Let's look at the tools. So IPL tools, team players, season signal, featured team players, resolve reference data. All these are tools. Get matches for query. So you can define your own custom tools or you can use MCPs externally to get the data out. And that's how you define it. Then it's important, guys, to run these tests and you test the IPL tool test. You run and test the tools. You have data loader.py, which is basically demo data, team aliases, player alias, and all these things. So that's how you write a code around it. And this code is being shared in the GitHub repository, which you guys should look at. And it's basically one example. Manually coded or vibe? Okay. It is neither manual nor vibe, Shashi. What we do is a concept which is agentic coding. How do you do that? You create a detailed, structured implementation plan in the document with the mechanisms in which it should be executing your code review cycle. So multiple agents work towards it. Now in vibe coding, you just ask it to do something, it does something. And there's a difference between these two. Moving forward, for example, in create bytes, the mandate is no engineer should be coding. How do you deploy this step on localhost? So yeah, it's localhost. But for example, one interesting thing I'll tell you, just search Cloudflare. Cloudflare can tunnel your localhost URL to any public IP. So it will basically convert your localhost URL to some public IP without doing anything. Like you can do it locally with 3 steps. And then with Cloudflare, you can give your demo to anyone sitting across the globe. So we do it a lot. So you guys should also know about this. Is called as Cloudflare. Any other question, guys? Before I am beginning and I'm building an AI powered learning system for my college. I have implemented RAG pipeline, but I'm not able to get around NLP classifier thing and TF-IDF things. Can you suggest some relevant resources? Okay. So first thing is, I want Ashutosh you to send me your plan and strategy because from the look of it, you're doing it incorrectly. When you're trying to build a learning system for my college, is it like a management system? If I'm not wrong, if you're building that, there has to be multiple things which you should be adding. But from here, you're using TF-IDF and NLP classifier. These things are not needed. So exactly which thing is being used for what, you need to send that to me. Maybe what you can do in the group or on the Insta, send a link of your document or something, what you're trying to build. And maybe I can look into it and see what you're doing. But the way I look at it is, first you build a learning management system. Okay. And then you can also build a personalized learning agentic system. And interestingly, I'm also doing something similar for CBXperts. So that's something which you can look into and build. Yeah. Nice. Thanks, Rama. And where it is committed, it's basically there's a repository. I think on just put it on Insta or on WhatsApp. Someone will text. So anything which you want to communicate, just send a link on WhatsApp, and uh, uh, I'll try to get involved and give you that. And the repo is present. Maybe Sarthak or Achal, guys, you can share the repo link with the team. For the timing, we can share it in the chat too. So you can see it here. Otherwise, best option is put it on the WhatsApp group or Insta channel. Any other question, guys, which you want to know and understand about? Or we can wrap the call today.
So GitHub repo.
Oh, GitHub repo. Yes, yes, yes. Sarthak, are you guys there? Okay, give me a second. I'm gonna send the GitHub repo at my end itself. Just give me 1 second. Here's the GitHub repo, guys. Take it and use it. LangGraph based. When we prepare a detailed specification, what is the expected product? What is the prompt we need to give so it reads and start writing the code? Now you're asking the right question. Okay, so when you prepare a detailed specification, uh, like in terms of the product specification, what you can do, I'll share. Okay, let's write it down. Let me share a very detailed product specification, how to define it. But what you can simply do, and I'll tell you my process, a practical process doing it. Go to ChatGPT or Claude, use your audio, and say whatever you want about the product. What do you want in the features of the product? So first step is define a product specification in detail and ask it to prepare a detailed product specification and use 2 3 prompts here and there. And like you can start with a simple thing and then let it define broader and broader thing. Then you create a detailed requirement specification from that. And when you're doing it, I can share a prompt template in which you can just fill in the information. But I strongly recommend do not just do it once. Follow a 2 3 repetitive cycle of iterations, because every time it produces an output, I'm telling you, you have two more things which can be added. So do an iteration with it and then finally create a spec. But once you create the spec, then you use the other prompt, which I'll send it across, which you use to ask the LLM to create a detailed implementation plan of 5 agents working on it, each agent doing this, which is like a multi-agentic mechanism of writing code. And then you create a strong prompt to ask Claude or Cursor to start working and executing this implementation plan. Okay, so first phase is defining the specification in a to and fro manner, then using the prompt to create an implementation plan the way I'm mentioning, and then putting a prompt to ask it to execute that implementation plan autonomously. Those things need to happen. Okay, cool. It would be great if you can share the prompts to execute. Yes, yes, yes. Let's do that. So I'll share it. Sadak, Ajal, let's write it down. I'll basically share it on Insta or WhatsApp group, and you guys can always ask questions here and there. Send email, and it'll be ask the question.
So this is related to Internet of Things, which I'm doing a project. I have little challenges while deploying it on Git or not using APIs. So I have to run it on a mobile app. It could be whether Android or a Mac OS. But then those are challenges when I try to deploy it. I don't get free APIs and all. What is the workaround? And if I don't want to use APIs, how can I solve it?
Okay, Rama, are you building a mobile application or are you building a backend system right
I
now?
built a backing system, but I have to integrate it with the front end because people have given me a proper feedback. Without the front end, without integrating,
Okay,
I
and that
cannot.
front is your mobile app.
Yes, that front end is
Okay,
mobile app.
and but you can run your
Using,
backend on
mm,
your local host, correct?
I can run it on localhost, but I'm facing few challenges because I have to integrate it with the front end. And front end, I have used Firebase as far as I have my credits. Now the credits are expired. Now I cannot use Firebase anymore.
Understood. Okay. Do you know why Firebase is being used for, or is what's the reason of Firebase? Notifications you were using it for, or database?
Yes, notification, not the
Okay.
no, because database I'm not maintaining any database. It is like
Perfect. Perfect. So
yeah.
see, yeah. So understand, Firebase is nothing but a broker.
Oh.
Okay. If you can skip Firebase and use a concept of queuing with RabbitMQ or Redis.
But for that I need credits, right?
No, Redis is
Mhm.
an open source thing. You just download and install it.
Okay, good, got it. Huh?
Okay. You don't need to depend on Firebase.
Great. Yes.
Okay.
Thank
And
you.
then there are other tools too which you can use, but usually just use RabbitMQ and Redis for notifications. It's an
Sure.
asynchronous mechanism, asynchronously send you notifications, at the same time update the backend for it, and you can integrate the backend and front end with that
If
individually.
you take 2 minutes of time and see my code base, then it will be more insightful for me. I'm not taking
Okay.
your personal time or other students' time as we are in the thing.
Yeah.
I'll post my link, GitHub link on the group chat. Would
Yes.
you be able
Perfect.
to look into it and suggest me?
Done, 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 Rama. So I think the team will be able to help you out, and I'll basically get involved. So one thing which you can do, and this is one of the best thing which I would like to do, is work and teach with the code. Okay. So do one thing. Is
Huh.
it like an open source GitHub repo?
Yes.
Okay. So put a link on the open source GitHub repo so that
Hmm.
it can be checked either on Insta or on WhatsApp, and then we can take
Do
things
you have
forward from there.
Insta account?
Also, your question.
Only
Okay,
GitHub.
maybe on WhatsApp group.
Sure, sure. WhatsApp group is only for announcements. I do not have access to that. I can only read the announcements, whatever you guys
Understood.
post. Yes.
Okay.
Generously give me your email ID, any of your team members.
Yeah.
Send
So
the
let's do one
GitHub
thing.
repo. Yeah.
Yes. So the team will share an email ID which is currently being used for GitHub repositories, Rama. So as of now, there is a workflow which is built for you to help in terms of scaling it up. So the GitHub repo goes to a code review. So you will not just get review about where you are stuck, but also how you should improve your code.
Great. That is
Okay.
really
So
helpful. Yeah.
yeah. So they'll share an email ID
Mm.
where you should send the GitHub repo link. Okay. Which will
Sure.
autonomously create. Again, this is built with agents.
Yeah. Yeah.
So yeah, done. Perfect.
Thank you.
Anyone else? Yeah. Thank you, Rama. Okay. So just like we'll remember and send it across. Anyone else having any question? Perfect, guys. I think we are good for now. It went ahead. Thank you. Thank you. I hope I'll be able to do much more in the next session. And if your friends, your colleagues, they also want to learn and grow in this domain, we'll be doing very interesting activities. I would like you to respond to the polls so that I can do different activities in different scenarios moving forward. Okay, done, guys. And you can invite your friends and other people too if they want to learn in that direction. Done, guys. Best of luck. All the best. Have a very good Sunday. Thank you. Bye bye.